Good evening, class. Today we will be talking about a way to prove triangles similar again. There's two other ways besides angle-angle similarity postulate. There's what we call side-side-side similarity postulate and side-angle-side similarity theorem. The first one, side-side-side similarity theorem, it basically is how it sounds. I'm comparing three sides of one triangle to three sides of another triangle. And if I have all three sides being proportional to the other three sides, well, then the two triangles have to be similar. In my example up here, I have 25, 20, and 15 on one triangle, and I have 10, 8, and 6 on the other. If I compare 25 to 10, 20 to 8, and 15 to 6, what I find is I don't know if they are equal yet. But if they are, I know that these two triangles have to be similar because of the side-side-side similarity theorem. So if I look, this reduces to 5 to 2. This reduces to 5 to 2. This reduces 5 to 2. They are equal, therefore the triangles are congruent because all three sides are proportional to the other three sides. And that's enough to show that these two triangles are similar. Let's look at a few examples of what I might ask you to do with this knowledge. Well, the first one is I might just ask you to determine whether the triangles are similar. If so, I want you to tell me their similarity statement. If I look at these two triangles on the left side, the only way I can tell if these two triangles are similar is if I have all three sides to be proportional to the other three sides. So what I have to do here is I have to set up a statement of proportionality and verify whether or not it is actually true. So I'm going to set up a statement of proportionality, but I don't know whether they're actually equal. I'm going to choose the longest side, 25, and compare it to the longest side here, 21. I'm going to choose the shortest side, 15. I'm going to compare it to the shortest side here, 12.6. Then I'm going to choose the last side, 20, here, and compare it to 16.8. If this statement is true, then I have two similar polygons, or two similar triangles. I look real quick, 25 and 21 cannot be simplified any further. So every time I reduce this from here on out, it'll be 25 to 21. But this next one here, well, the easiest way for me to do this is multiply the top and bottom by 10. So I get 150 over 126. The last one, same thing. I have a decimal, so it'll be easier for me to multiply the top and bottom by 10. I get 200 and 168. Now, if these are similar, I should get 25 to 21 for each of these. So, how many times does 25 go into 150? 6 times. So let's divide the top by 6, and let's divide the bottom by 6. 6 goes into 126 21 times. So the first two statements are in fact proportional. Now what I have to do is make sure that the last side is. So how many times does 25 go into 200? 8 times. So let's divide top and bottom by 8. So I get 25 over, oh, look at that, 21. I get the same ratio for all three side lengths. These two are similar. And I was told that if so, write a similarity statement. So triangle ABC is similar to triangle. I have to be careful of the order. If I go ABC, I have to make sure that I'm also going DEF. Because segment AB is the longest segment. Segment DE is the longest segment. Segment BC, shortest. Segment EF, shortest. It matches up. Similar has to match up. So there I go. First problem done. The next pair that I'm going to have to do, I look at, and, well, it ends up being the same letters for my triangle. However, I still have to check using the side-side-side similarity postulate. So let's make our three ratios. Longest side is 30. Longest side over here is 25. So 30 to 25. Shortest side over here is 20. The little shortest side over here is 17.5. And now the last two sides I haven't done so far, 24 and 21. So I'm going to reduce each of these fractions as far as I can. Well, this one I can reduce to 6 to 5. Divide the top and bottom by 5. This one is a decimal, so let's multiply the top and bottom by 10. So I get 200 to 175. And this one here, let's see, I believe 3 goes into both of them. So this one becomes 8 to 7. Wait a second. 6/5, 8/7. I think that's 2 different numbers. Let's just verify. 6 to 5, does it equal 8 to 7? Well, if it does, the cross product should work out. So 6 times 7 is 42. 5 times 8 is 40. That doesn't work. These two aren't the same. All I need is one set of sides not to be the same, and I can automatically now say not similar. I have one part of my proportion failing. So therefore, those two triangles are not similar. These two are similar because all 3 work. These two aren't because at least one pair of sides has a different ratio than the others. Alright, so the next part. What if I gave you 3 of these and I said, determine which one is actually the one similar to this triangle over here? Alright, I look at this. If I want one of these triangles to be similar to this one over here, I know that it's either this one or this one. So in honesty, I only really need to probably check one here to verify which one is. However, I will be checking both. So the first one over here, I'm going to put 3 ratios here. And then for this one here, I'm going to put 3 ratios here. I know that only one of these 2 sets will work. And the 2 triangles I'm going to compare are this one to that one over there, and this one over here to that one over there. Well, longest side over here is 25. Longest side over there is 15.5. Smallest side over here is 15. Smallest side over there is 9.3. Medium, 20. Medium, 12.4. Let's set up this one while we're at it too. The longest side for triangle DEF is 21. Longest side for triangle GHI is 15.5. Shortest is 12.6. Shortest here is 9.3. Medium, 16.8. Medium, 12.4. Only one of these 2 ratios should work because it said either. But just to make sure Mr. H didn't make a mistake in his calculations, we are doing both. Well, any way I look at this, I have a decimal in my answer. So what I'm going to do is I'm first going to get rid of all decimals by multiplying top and bottom everywhere by 10. Alright, now that I got rid of all decimals, it's just a simple matter of reducing it as far as I can go. Both of these end in a 5, so it's a 5 or a 0. So let's divide top and bottom by 5. I get 50 over 31. I believe 31 is prime. So that means this one here can't be reduced any further. So if I want this one to match up to this one here, I need to divide the top by 3. So 50 over 31. Ha! I got 2 to match up. Now all I have to do is verify that the third one matches up, and I've got this one good to go. Well, 50 has to go into this 4 times, so let's divide the top by 4. That means I also divide the bottom by 4. Oh, this one works. So my answer would be triangle ABC is similar to triangle GHI. However, Mr. H could have made a mistake, so let's just verify over here that he did not. So let's divide the top and bottom here by 5. 42 over 31 42 has to go into this one 3 times. Ooh, I'm getting 42 over 31. All right, let's try this one. 42 times what equals this? Well, it's 4. I think Mr. H made a mistake here. Yep, I made a mistake. I made them so it was both. Whoops. In reality, though, what should have happened was I should have made a mistake in one spot, or one of these wouldn't have worked. You would have gotten at least one of these ratios to not be the same. In this case, it ends up being that all 3 are similar. It was not intentional, and I'm glad I checked because somebody might have asked, "Hey, I found triangle DEF to be similar." Yeah, I was trying to go for one or the other, but I made a mistake when I was computing the numbers. I was actually being too accurate and too correct. Oh, of course. But all 3 ended up being similar in this case. It was only supposed to be 2 of them were supposed to be similar. That's why we verified that all of them are, because or it could actually be both. All right, for the next thing that we need to talk about, we are going to do another example. It's what additional piece of information do you need to show that triangle ABC is similar to triangle DEF? Well, it just so happens I have some information already up here. So let's keep some of it. So, in the first one I'm given, number 1, I am told that segment AB to DE equals segment BC to EF. What do I need to know to make it similar? Well, if I'm doing this by side, I need to know what the last ratio is. So let's see. AB, DE. So this side is taken care of. BC to EF, that side's taken care of. Well, all that's left is AC and DF. BC is on top, so I start with AC on top. And I'm comparing it to DF. So what do I need to know? That part, but I would still write the full statement that this is equal to those ratios. All right, well, let's try question 2. In fact, why don't you try question 2 on your own quick? So, in number 2, they gave me this information. Well, if it's side, I'm trying to do this, I need to know that last ratio. So this part is the part I need to know. Well, let's mark off what I know. I know DF to AC. I know DE to AB. The only side I don't have yet is EF and BC. So let's use side EF to side BC. And this is what I need to know, but I would still write out the full statement of proportionality just to make sure that you understood that that's what it needs to be equal to. Alright, so if I'm trying to prove triangles are similar by side, I need to essentially show that this statement is true. Alright, there is one last shortcut that we can go over, and it's side angle side. Just like side angle side in the other triangle, when we were talking about congruence, what I need to have happen is I need to have 2 sides, for instance, this side here, and this side here, and the angle between them to match up to 2 sides over here and the angle between them. Now, the side lengths aren't going to be congruent. They're going to be proportional. Because it's similar. It's not if the triangles are congruent, it's if the triangles are similar. So the sides have to be proportional, and then the angle between them has to be congruent. Remember, angles of similar triangles are congruent. So if I have the angles between them being different numbers, it's definitely not similar, even if the sides are proportional. So the 2 sides being proportional to 2 sides and the angle between them being congruent. That's all you need. And then you can say the triangles are similar. So in this scenario, I'm going to be asking you, determine whether the triangles are similar or not. Alright, in the left one here, when I look, first of all, I'm going to check the order. Side, angle, side, yep, it's 2 sides and the angle between them. Side, angle, side, yep, it's 2 sides and the angle between them. Now, is that angle congruent? Yes, it is. Condition 1, angle B congruent to angle E? Check. So now, if I'm trying to prove that these two triangles are similar by side, angle, side, I need to show that their sides are proportional. Now, how it should go is that the longest side to longest side. So 25 to 22. It should also go then shortest to shortest. 15 to 13.2. Now that I have the proportion set up, if this is true, I can now say those two triangles are similar. Well, what I need to do is I need to cross multiply. So 15 times 22, I believe I get 330. 15 times 22, I believe I get 330. Now if I do 25 times 13.2, let's see, 5, 75, so 80. Wow, I get 330 again. So, is it true? It is. So the sides are proportional. I know that these triangles are similar. You see, it didn't ask me to say similarity statement. I'd probably just do this. But if I wanted to be a little bit more official and a little bit more mathematical sounding, I would do this. Alright, so for the next one here, first let's check the order. Two sides and the angle between them. Two sides and the... Wait, that's not the angle between them. Two sides and... It's not the angle between them. I don't even have to try this. I cannot determine. Not enough info. There just simply isn't enough information. I cannot determine if these triangles are similar or not. They very well could be. But I have no clue. I don't have the order I need. I need either angle, angle, side, 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 or side, angle, side. So there I go. These triangles cannot determine if they are similar. Alright, the last example for this section, I'm going to ask you to sketch the triangles using the given description, and then explain whether you can determine if the triangles are similar or not. So, in the first one, I see it's triangle ABC and triangle DEF. I also note that there are some information like angles about it that I could say. I would like you to, first of all, try and just draw these triangles to the best of your ability. Alright, now that I have my 6 triangles ready to go, now it's all about filling in the information. I see that they say measure of angle A is 55 degrees. And measure of angle B is 45 degrees. Okay, they say measure of angle D is 55 degrees. And they say measure of angle F is 80 degrees. Alright, if I look real quickly, I have 2 angles and 2 angles in number 1. So that makes me think angle, angle. However, I see that 55 and 45 doesn't match up to 55 and 80. However, I have at least one angle match up. Well, what's the last angle here? Well, that's going to be measure of angle E plus 55 plus 80 equals 180. And if I solve, wow, I get 45 degrees. Oh wait, so I do have 2 angles matching up. So those 2 triangles, I can determine if they are similar. There is enough information, and it would be angle, angle, angle. Sorry, it would be angle, angle, similarity postulate. Alright, so the next one, it doesn't actually tell me what side lengths are which. However, but it gives me 3 side lengths and 3 side lengths. So I'm just going to throw 5, 6, and 7 like this. And correspondingly, I'm going to do 6, 7.2, and 8.4. So, if this is true, I need to do a statement of proportionality and see if I can get it to work. This is the one I decided to set up myself. Now, the first step I'm going to do is get rid of all decimals, so I'm going to have 84 over 70. I'm going to have 72 over 60, and I'm going to have 6 over 5. That can't be reduced. Well, if I want this to be true, I need to get them all to be 6 over 5. So how many times does 6 go into 84? 14 times. So is this divided by 14, is it 5? Well, it actually happens to be 6 to 5. The middle one, how many times does 72 get divided by 6? Well, 6 can go into 72 12 times. 60 divided by 12 is 5. So if I simplify all of these here, I get 6 to 5, 6 to 5, 6 to 5. So I know similar by side, 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 similarity theorem. Awesome. All right, the last one, filling in the information. Mn is 25. Length of segment NP is 20. And angle N has a measure of 65 degrees. Awesome. Then in triangle QRS, I have QR, length of segment QR to be 21, length of segment RS to be 16.8, and I have measure of angle R to be 55 degrees. Hold on a second. These angles don't match. And of my three options, angle, angle, side, 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 and side, angle, side, well, if the angles don't match, I better have all three sides. But if the angles don't match, maybe it's one of these other angles and other sides that will cause it to be similar. I don't think I have enough information because I can't do it this way, I can't do it this way, and this one, the angles don't match, so I can't do it that way either. So this one, not enough info. And there I go. These are the types of problems you'll see. Can you determine if the triangles are similar? If you can, set up the proportions, solve for something. Alright, it's a lot of the same stuff that we've been doing, just now we have a different shortcut, different ways to show it. You have three total. Angle, angle, side, 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 and side, angle, side. Use them at will to show that triangles are similar or not. Till next time.